Hello. The question I'm going to be doing today is from Chapter 12, Rotational Motion. And first of all, I'd like to say I've written a few of these points down, such as the question and the three big ideas, because this is my second time recording, and I took approximately 18 minutes, where I had to be in the 7 to 10 minute range. So I just wanted to write a few things down just so I could speed up the process. So, getting on to the question, there's three big ideas for this chapter. Big idea number one is Newton's second law, and the second big idea is the conservation of energy for rotation, and the third big idea is conservation of angular momentum. So, for the problem today, we are going to be working on the conservation of energy for rotation. And in this big idea, there's the one main equation that we follow, which is the kinetic energy initial plus the potential energy initial is equal to the kinetic energy final plus the potential energy final plus the change in other energy, which is delta OE. So, for the kinetic energy initial, there can be two parts, which is the translational kinetic energy and the rotational kinetic energy. The translational kinetic energy consists of 1/2 mvi squared. The rotational kinetic energy consists of 1/2 I omega squared, and the omega can be omega I. Both of those are for kinetic energy. For potential energy, it's going to be the mass times the gravity times the y initial, which is the height. Again, on the right side, it's if there's translational rotation energy, which is if the object moves forward or backwards, it'd be 1/2 mvf squared. As well as if there's rotational kinetic energy, it'd be 1/2 I is the moment of inertia, omega final squared, as well as the change in OE, or the change in other energy, which is 0 for our problem, because a change in other energy consists of thermal, chemical, and nuclear energy, which our problem does not consist of. So we would have a value of 0 for the change in other energy. So our problem says, calculate the moment of inertia of a skater given the following. The 60-gram skater is approximated as a cylinder that has a 0.110 meter radius. So our first step would be to draw a cylinder. The second step would be to draw the radius, which is 0.110 meters. So we would use, and for this one we have to find the moment of inertia. So moment of inertia would be I, which if we go to our picture, we can see it is, for a pulley, for a cylinder, it is 1/2 mr squared. So we would say moment of inertia is equal to 1/2 mr squared. And if we plug this into the calculator, we'd get, or if we say 1/2, the mass is 60, and the moment, or the radius is 0.100, or 0.110, excuse me. We would get 3.3. Just a second. $110 times 60 divided by 2. Yep, 3.3. And the units are kilogram per meter squared. So that would be the moment of inertia. And then for the second part, we would have the skater with two arms, which is so the skater, and that would be the cylinder, and the two arms would be the arms in the question. So we would draw a cylinder, and then we would also draw dotted line, draw the radius, which is 0.110, and then we would say the distance would be, the length would be 0.900 for both, and the mass would be 3.75 kilograms. So for the arms, so this would be arm 2 and this would be arm 1. For the arms, we can say the moment of inertia for the arms is equal to we can check our picture, which says it would be, for a rod pivoted at one end, moment of inertia is 1/3 ml squared. So we would say 1/3 ml squared, which would be 1/3 the mass, which is 3.75, times the L, which is 0.9, squared, which is 1.125, and then we would time this by 2, because there's two arms, so 2 times 1.125 is equal to 2.25. Additionally, we also have to find the mass of the cylinder, which would be which is 1/2 mr squared, which is equal to, the moment of inertia of the cylinder, which is 1/2 mr squared, which is 1/2 times 52.5 times 0.110, which is equal to 2.8875. And then we would add together the moment of inertias, which is 2.8875 plus 2.25, which is equal to 5.13.